you just gave me an answer with no explanation. You know what I mean?
That makes more sense.
Yeah, you know, I want to know your thought process. All right, go ahead, Antonio.
Okay, so basically I knew the range. First, what I did is I put the normal cosecant function, which is y equals cosecant of x. I seen that and I realized that the asymptotes were already placed needed to be. So now I didn't have to do any vertical shifting, which means the x was going to stay the x. But then I seen that the range was off. So I tried doing first vertical shifts up and down. It wasn't getting me where I needed to be, so I started messing with the number in the front. And eventually I ended up finding out that it was y equals 5 cosecant of just plain x minus 3. And that gave me the range where it needed to be, and then of course no side to side, I mean these are the same. And so the A would be 5. That's the asymptote. K I think would be 1. K would be 1, correct?
Correct.
All right. And then the phase shift is 0 because there is none, and the vertical is down 3 or y equals negative 3.
Perfect. Yep. So this would be like number 3 under TGA. And everything that you described, I would expect to see you write that, whether it's bullet points or a paragraph. Like maybe if you did amplitude 5 and you described how you found it, whether it's you just kept changing the number until it matched, or if you actually went the mathematical approach. And probably a mathematical approach that you'd want to do is looking at these the range here, and how from -8 to 2 you have a gap, and the absolute value of -8 minus 2 is 10. So the gap is 10, and half of that would be the amplitude. So mathematically, if you describe something like that, and I would take that too. But if you just said you just guessed and checked until it fit, that's fine too in Desmos or in GeoGebra. Your K value is the coefficient in front of the X variable, and it was perfect what you said. When you graph the original, and that's key, everyone should graph the original. And when I describe you the 2 consecutive asymptotes, one being at 0, one being at pi, those are vertical lines. And if you graph it and you see the original has the exact same asymptotes, that tells you there was no horizontal shift, also known as the phase shift. So that was good that you noticed that. And then for the vertical shift, like you just said, you kept playing with it, but there is actually a formula, and I'm going to go over that formula today. So just stay tuned for that formula and actually how to find the vertical shift based off of the like the min or the max value that you're given. So nicely done. Okay, everyone. This is day 1 of only one of this lesson, 3.05. We only have 1 day of this. This is real-world applications of the trig functions. Make sure your hand is all stretched out because there's a lot of writing involved and a lot of thinking. All right, we're being recorded. All right, you may want to snip this page. So I was so nice enough to put some important formulas all in one place versus kind of scattered in this lesson. Everyone should know the formula for period. It's either 2 pi over k or pi over k, depending on what we're dealing with, right? If it's pi over k, if it's tangent and cotangent, and then it's this first one if it's everything else. That's important. What I described on the bell work, talking about vertical shift here, let me do this one first, amplitude. So amplitude, you can guess and check in Desmos, like on the bell work, or given the maximum and minimum value, which that gap gives us based on how that's graphed. It is the max, the min, and you just subtract and divide by 2, and that would be the amplitude. Vertical shift. You have, well, I derived two formulas. There's probably more than just two, but these are the two that were probably that came the easiest to me. Vertical shift, you can find that by taking the maximum and then adding the minimum. See how they're different. This is subtraction, this one's addition. It makes a world of difference. So the max plus the min, and then divide that by 2. So going back to this problem here, these would be the min and the max values here. If you graphed it, you would see that. So you would have -8 plus 2, that is -6, and then -6 divided by 3, sorry, divided by 2 is -3. So that tells us a vertical shift of down 3. So that's a mathematical way of finding it. Or we could take, if you know the amplitude and you know a max value, you can take the max and subtract the amplitude and get the same shift. So let's go back to this one, and this one's a little different because it's cosecant and it's you have the gap in the middle. So let's see if it still applies to this. If we have 2, which would be like a max value technically, because it's greater than -8, even though it is considered it's called a local min, but is compared to these two, this is the larger value of the two. So it's kind of, I guess, deceiving when talking about cosecant and secant functions. In this case, it's actually a local min and not a max. But anyway, you're going to have 2 minus 5 gives us -3, so it is shifting down 3. So I guess, it doesn't really hold true for cosecant and secant. This would be more of like a max value, not necessarily a local max. There's a difference. Okay, and yes, you do have another quiz today. Yeah, after this lesson. All right, so first question, the clock. All right, volunteer wants to read this to us. All right, go for it, Emily.
Clock. The pendulum on a grandfather clock moves the same distance from its resting position straight down to the right and to the left. Graphing the distances moved to the right as positive values and to the left as negative values results in the graph of a sinusoidal function. F of x equals 10 sine of 2 pi x over 3 gives the distance in inches that a pendulum moves right or left x seconds after the clock chimes. Consider a cycle to be the pendulum moving from its resting position to the right, to the left, and back to its resting position. How many cycles does the pendulum complete in 1 minute?
All right, very good. All right, so for your word problems on your quizzes, on your test, and if the problem gives you an equation, what should we do right away? Yeah, graph it. We should go to Desmos or GeoGebra and we should graph it to see what it looks like. So let's everyone do that. I'll give you a moment to type that in. All right, and then I'm going to share my screen, and we can talk about it. All right, everyone see my graph? All right. So you can kind of think about, so it tells us when it's positive, it's swinging to the right. When our graph is negative, it's swinging to the left. And then when it's at the x-axis, well, it's right in the middle. So that should make sense. All right. And what is the, looking at this graph, what is the amplitude of this? 10. Yeah. And we can see that it goes maximum of 10. So from the midline, which is the x-axis, because there's no vertical shift, it's a distance of 10. So that means the amplitude is 10. Well, that makes sense because, well, there's a 10 in front of our sine function. So we go from 10 to negative 10. All right. Starting at time equals 0. So the x-axis would be time in seconds. And then the y-axis is the distance from the midline. All right. Now looking at this graph, can we tell how much time it takes to do a full cycle? So from the middle, it swings to the right, it swings to the left, and then it comes back to the middle. Can we see that on the graph? Yes, we can. And what is that time? On your graph, you can zoom in a bit because everyone should graph this. So looking at the graph, what is that time? We got one person that gave an answer. Are we just typing 3 because we agree with Chloe? Chloe, one time, or maybe multiple times, I want you to give a wrong answer that's pretty close to the right answer, just to see if people actually follow you. I'm curious. So yes, it is 3 seconds. So it swings to the right. Oops, clicking around. Let me move it back down. So it swings to the right, and it swings to the left, and then it swings back to the middle. So in that point, if I click it, shows, in fact, it is 3 seconds. So it takes 3 seconds to do a full cycle. And I think that's one of the questions. So I'm going to stop sharing this because I think we got enough from it. All right, there we go. It's too much work going back and forth. All right. So this first question, it says, how many cycles does the pendulum, or sorry, how many cycles does the pendulum complete in 1 minute? Okay. So in order to answer this question, we need to know first how much time it takes to complete 1 cycle. Or what's another way we could do this? There's probably, the way that I'm going to show is probably the complicated way. The easiest way to do it is, well, you'll see. So we got some explanations in chat. 60 over 3 is 20, so 20 cycles in a minute. So we say, so Caitlin says 20, Chloe says 20, Jacob says 20. Well, let's take a look. So one way we could have done it was look at the graph, go out to x equals 60, and then count how many times we get back to the midline, right? That's one way to do it. Maybe not the best way to do it. But let's see. All right, so the period, we already figured this out, that it was 3 seconds per cycle. And we saw that graphically, but mathematically, that's what we did. And then a few of you described the conversion. we must convert 3 seconds per cycle to, well, cycles per minute. So that means if it's 3 seconds per cycle, that means it's 1 cycle every 3 seconds, right? Isn't that the same thing? So I'm setting up a ratio here. It's 3 seconds per cycle. All right, and we just convert seconds to minutes. How many seconds in a minute? 60, yep. So there's 60 seconds in a minute. And if you're wondering why I'm doing cycles over seconds instead of seconds over cycles, well, it's because the problem says how many cycles does the pendulum complete in 1 minute? So it's asking cycles per time. So we know time goes in the bottom and cycles goes on the top. So that's why I wrote it like this: cycles over time. That time needs to be converted to minutes. To do that, we have 60 seconds in a minute. So seconds and seconds cancel out, leaving us with cycles over minutes. And we just do the math. 60 over 3 is, in fact, 20. Not too bad. All right. Questions on this? Nope. All right, let's get some harder problems out of the way. All right, so same problem. We got the clock, but now the question states or asks, where's the pendulum 8.25 seconds after the clock chimes? All right. So everyone try to figure this out. I'm going to give you all, say 1 minute, ready to go. X is seconds, correct. Twenty seconds left. Hints. Emily gave you a hint. She says X is seconds. Plug it in. So remember, so X is seconds, and then Y, your output, also known as your dependent variable, is the distance from midline. But it's a decimal. What do you mean it's a decimal?
I mean, like Kate said, you should use radians. So I meant like, but it's the time is a decimal. It's an 8.25.
Correct. Correct. Now, okay, so I think what she's saying is when you type it in, make sure your calculator is in radians. So yes, that's true. Yeah. Yeah, make sure your calculator is in radians. Right. All right, so what's the answer? In words. So again, the question says, Where is the pendulum 8.25 seconds after the clock chimes? I want, remember, this is a word problem. I want an English answer. I don't want a coordinate. I want you to tell me the answer that you get. Tell me what that means in words. To somebody who's not in pre-calc and is asking you, hey, where's the pendulum at after 8.25 seconds? Where is it at? So we got 10 inches to the left. Remember the clock swings left and right. It doesn't swing up and down. It swings left and right. I hope not. All right, so it is. You are correct. It is. It's a -10, which is a minimum. So the pendulum is to the left. The pendulum is to the far left. Okay, I wrote that right. Yeah. So it's a minimum. So it's to the far left. You can say to the far left. You can say all the way left. As long as you're telling me that's to the, well, far left. And yep, Emily was correct. We're we're plugging in 8.25 into the function. So that's where 8.25 goes. And you type that in. You want to make sure your calculator is in radian mode. And when you hit enter, you will get -10. If you are not in radian mode, I do not believe your answer will be anything close to that, but I'm not sure. Yeah, so for your tests that you have next week, and obviously this quiz, hopefully all of you have been doing the learn and practice module examples like you're supposed to practice. You're doing the quizzes, typing stuff in, writing stuff down. And you know when to change from decimal to radians, because it does matter. I'd hate for you to miss every problem because you're in the wrong mode. All right. Questions on this one? So guys, just remember, every word problem that you have is going to be some type of like sine, like a sinusoidal wave, whether it's sine, cosine, probably not tangent. But just know that it's going to have a max and a min, and it follows that pattern. No matter how crazy the word problem sounds, because the one on your test sounds kind of crazy a little bit. The way they took this sine wave, whatever problem that you're going to have, and they put it into this word problem. It like doesn't really make sense to the situation, in my opinion. But you're given a table of values like this problem here, and then it asks you some questions about it. So, yeah. Okay, volunteer to read this for us. Come on, there's some good readers here. I'm not one of them. All right, Antonio, I guess you can. Julia, you can do the next one.
A snail is sitting on the outer rim of a water wheel. The table shows the height of the snail above the ground above ground level as the wheel rotates.
All right, and this, I put a picture of a water wheel because a lot of you may not know what a water wheel is, because we don't actually have a whole lot of water here in Arizona to have water wheels, right? So yeah, that is a water wheel, and they can come in many sizes. Like there's huge ones and there's small ones. So I think a purpose of a modern day water wheel would be a generator, an electric generator, in rivers and also in waterfalls. So Emily, have you seen a water wheel in person then, living there? Yeah, okay. You think so? Good enough, good enough. I'll take I think so. All right, so it tells you have your time, and then you have your height. So this is probably your x values, and this is going to be your y values. Independent variables is time, dependent is your y. All right, so what is the water wheel's circumference? All right, we got to find the circumference of this given this data. Anybody have any ideas how we can approach this? Find the radius of the circle. I think that's excellent. Okay, how do we find the radius of this water wheel first? Amplitude. So Emily, are you telling me that amplitude and radius can be the same thing in these problems? Yes, and you are correct. Yes. So if you think about this wheel spinning around, it's going to have a max and it's going to have a min, just like the wave, right? Well, the max and the min, well, half of that distance is the radius. But if you were to graph this, was it a sine wave we're talking about? I don't know if it says sine wave. I think on the next page we'll describe what it is. Okay, we'll say sine wave. When you graph the sine wave, the amplitude represents the radius. Very, very good observation. Very good observation. All right. So, knowing that now, what is the radius of this wheel? I'll give you time to write stuff down and crunch the numbers. Yeah, sure. You can give me a fraction if there's a fraction. Or decimal's fine too. 55 over 16. 2. Yeah, you guys are all over the place. So someone who got a fraction answer, what did you use to set this up? All right, let's do this. So what's the maximum here in this table here? What's the maximum? 6.875. Good. What's the minimum? Negative 1.125. Okay, so you know the max, you know the min. How do you find the distance between them? The max minus the min. So you have a positive number minus a negative number gives you what? So was it 6.875 minus negative 1.125? Type that in, or you do it by hand, and what do you get? You get 4. So the distance is 4. Or not 4, 8, right? sorry, not 4. The distance is 8. From the top to the bottom, the distance is 8. And then half of 8 gives you 4. Yeah. So the radius is the diameter divided by 2. And to find the diameter, we have to take the max value minus the min value and divide that by 2. And that's how we get 4. So 8 divided by 2 is 4. And from what Emily said, because we know the radius of this wheel is 4, that is the amplitude. So in this scenario, the radius and the amplitude go hand in hand. Good, good. All right. So we know the radius. Now, how do I find the circumference? Well, so it looks like quite a few of you need to look up the formula for circumference. Jacob, nice job. Pi times 2 or 2 times pi? Well, 2 pi r, that is. I think you forgot a little piece. Oh, you have it in there. I see it. PIR. Radical or square root of 2? Oh, no, sorry. That is, I think you meant times, not caret. Yeah, circumference is 2 pi r. Or pi times the diameter. You know, I always remember circumference as 2 pi r. Or it's pi times diameter. Same thing. Well, we know the radius is 4, so I just do 2 pi times 4 is 8 pi, which is 25.1 feet. Type that in and make sure that you can round correctly. I had a little mini lesson about rounding a week or two ago with some people, so hopefully you know how to round. If not, let's talk to me. We'll figure out a time we can go over that. All right, so next question says, how many degrees does the wheel rotate every second? Ideas on how to approach this. Think about the table of data, what's going on in the problem, what it means to... Yeah, this is like a two-parter. Ideas on how to approach it. How about observations? Do we know anything about rotations and time based on the data? So it looks like a bunch of you are typing. Hold on, let me see. Divide the change in height over the 4.5 seconds by 4.5. That would be good if it wanted to know the actual change in feet, but we want the degrees, so that would not work because we want degrees and not feet. Good guess, though. Antonio says, so went all the way around in 18 seconds. That is a good observation. I like that one. Unit circle only with a radius of 4. That might work, Chloe. I think that might be Yeah, that might work. I don't know if that would be easy or not, though. So Antonio's observation is probably the best one that I read so far in chat. So he noticed it takes 18 seconds to do a full rotation. That is true, Antonio, but remember the problem wants degrees and not feet. So we couldn't take the circumference and we couldn't like divide it by 18. That would be the feet per second, but we want the degrees per second. All right, Caitlin, there we go. So after 18 seconds, it's 360 degrees. You are correct. So if we take that fact, that 18 seconds per 360 degrees, how can I create an equation that will tell us the degrees per second? Why is it 20 though? Oh, you just did 360 divided by 18, and it gives you 20. Yeah, it's actually a good reasoning too. Why didn't I think of that? So Antonio said that the period was 18. So yeah, we could use the fact that it's 18 seconds for 360 degrees. So I just did half. I did 9 seconds for a half rotation. Same thing, right? If it's 18 seconds for a full, it's 9 for a half rotation. I could have very easily used 18 and 360. But I used 180 and 9. Doesn't matter though. It doesn't matter. It's the ratio is the same. And then I just set it equal to. I created a ratio that you learned probably your freshman year. If it's 180 degrees for 9 seconds, how many degrees for 1 second? So, that was my approach. And we just do the math, right? We just solve for x. So when you do that, you just get exactly what you guys said. Take 1/8 or take 360 divided by 18, and you get 20. It's the same thing of me taking 180 divided by 9. I still get 20. So yeah, 20 degrees. So your guys' approach of thinking about just doing the 360 divided by 18, that works for this problem. Yep, mine had extra steps because I actually created an equation out of it. I like equations. What can I say? So the thing with these word problems is they're all different, and they're all going to ask you different questions, and the approach to them could be very different. And that's why you got to kind of sit back and think about, what I'm trying to figure out, what do I need, and what's the way I can approach it. So every problem's gonna be different. There's not one way to do every problem. And some of these you're going to kind of sit back and think for a while. And I know, like during live class, we have a limited time, so the time that you all need to actually think about what's going on, or graph it, or draw it out, or whatever you got to do is probably going to be longer than the time we're going to have in class. So I understand that. All right. Same problem still, but now the question switches to. All right. Raj noticed that the data starts on the midline. So he modeled the situation with a sine function. So it is sine. And chose to make alpha negative because the value first decreases. Okay, that makes sense. So remember, when your amplitude is negative, rather than going up first, if it was sine, it would go down first. So that's a good observation. What equation did Raj model the situation after? Okay. So we know the amplitude, and we know the period. We figured that out on the previous page. So that's given info from the first page.
Danik has a question.
Yes. What's the question?
Says never mind.
Okay. All right. So we have amplitude. We have period. What else do we need to know? To create this equation, what else do we need to know? Well, we have the period. We got that from last page. Shifts. Yeah, we need K in particular. We do. So how do I find K? Well, we need the shifts and K, but let's find K first. How do I find K? We're going to use P equals 2 pi over K. Yep. So let's plug in, and we know what P is. P is 18, so we just set that up. Nice job, Jacob. If 18 equals 2 pi over K, and we're using 2 pi because it's sine. If it was tangent or cotangent, that would become pi instead of 2 pi. So don't forget that. All right, everyone solve for K. What does K equal? Pi over 9. Nice job. All right, we're getting closer. All right, now what do we need to figure out? The shifts, yeah. Phase shift and vertical shift. Let's do vertical shift first. That's an easy one. How do I find vertical shift? I'm going to give you a hint. I gave you that page of formulas with some good info. The max minus the amplitude, right? Yeah, so that's one of the formulas. So what does that give us? So you plug that in, you work it out. What's the answer for vertical shift? So the height is 2.875. That sounds kind of right, I think. Yep. We also could have done the max plus the min, divide that by 2 to get the same answer. So I have the work for doing it both ways just to show that it works. and then we just write the equation.
Question really quick.
Yep.
This is the amplitude, right? -4?
-4 is the amplitude.
Okay, it's maximum minus amplitude. So wouldn't
Okay.
a minus, wouldn't that become
So
positive?
let me so the amplitude is in fact 4, but because in this problem here we're making a negative, and that's because in the table of graph it starts off by going down and not up. So
Okay, I got you.
so I should have actually put +4 on this page, but when you actually wrote the problem out, let me move my little box. It's -4 sine. So it's a good point. Remember, amplitude is always positive. I actually shouldn't have wrote it like this on this page. I'm going to fix it. There we go. You saw nothing. It's negative because it reflects, and that's what it said in this problem. We're making it negative because it's, instead of going up first, it goes down first. All right, and we just plug in the other stuff. There is actually a third part to this problem to figure out the phase shift, and I actually forgot to do it in this problem. Everyone type that in and see if this equation matches this table of data. So if 0 at x equals 0, we get 2.875, we're good. We do? Okay, good. Then we don't have to worry about phase shift. Whew, dodged a bullet. So I have an example coming up here pretty soon that has us calculate phase shift. Just do 0 for x. Yep, and sine of 0 is 0. So yeah, that works. You so smart. All right. All right, another problem, sales. I'm running out of time too, uh-oh. All right, let me see how many examples we have left because we have 5 minutes left. 1, 2, 3. Yeah, we have 3 examples left. Yikes. So we're gonna go over on this on my time. I'm gonna keep going just to finish it, but if you have to go because of electives or something else going on, feel free to leave, and you can watch the recording later if you'd like to see more examples. So, yep, just stay as long as you want, and I'll just keep going. I think going over these is important because they're all very different. All right, sales. So the table shows the monthly sales amounts for a frozen yogurt company. All right, says Haley wants to model the sales with a sine function in the form of f of x equals amplitude times sine of k times x minus c plus h, where x is the month number making January 1, February 2, and so on. Haley wants the value of amplitude to be positive. What value should Haley use for amplitude? All right, so use what we kind of learned last question. How do I find amplitude? Max minus min. And then divide by 2. Yep. So 9.3 minus 2.1 divide by 2. So remember, I gave 2 formulas for amplitude, I think. So the one that works in this problem is max minus min divided by 2. So that's how we get 3.6. All right, what should she use for h? So again, I gave you a formula to finding the height. What is that formula? Amplitude times 2? No, remember, h is your shift, so we're trying to figure out the shift. So look back at the formulas that all of you wrote down or snipped and that you have in front of you right now. Well, one person wrote them down. Max minus amplitude divided by 2. Yep. So yeah, we know a max value, we know the amplitude, and we can divide by 2, and it is addition. So remember, this one's addition. So guys, those formulas, I have them up here for a reason at the beginning of this lesson for, to help you, and all of you should have snipped these or wrote these down. It takes the guesswork out of formulas. Max minus amplitude works too. And that's why I have them both there, to show that we get the same answer. Yep, I'll post a link right now to the slides for people that have to go. All right, so we figured out amplitude and the vertical shift, relatively easy, I think. So we're going to apply that to the second half of this question. I went ahead and I just copied our answers from the previous page here and here, because we have to answer this question now. All right, so we want to create the equation. So x is the month. First question, what should Haley use for K? Well, I gave you the formula already, so we know what P is. Well, do we? Do we know what P is? What is the period? Well, first of all, what's the definition of a period? How long before it repeats? So if I have January 1, February 2, March 3, and so forth, how long before it starts to repeat? 12 months. That makes sense. And Caitlin, you got it right. I know I saw that. So it is 12. So our P is 12. So it's important to understand what the definition of period is, so you can actually pick it out of a problem. And period is how long before we start to repeat our sine function. And after 12, it repeats, starting with January again and February and so on. So we just plug that stuff in, we solve for k, and that's how we get k is pi over 6. All right. So we plug in the stuff that we know. We plugged in amplitude. We plugged in k. We plugged in 5.7. Now I kind of jumped ahead here. So this is where the phase shift comes into play. My variable c here. So because I'm trying to think how to word this. It doesn't matter which coordinate we choose for this step. So this problem is forcing us to use 6 comma 8.2. So 6 is the 6th month, so that's June. So we're using June and 8.2. We're plugging this in to this equation we derived with what we currently have. And we're doing this to figure out what C is, what the phase shift is. We could have used any coordinate. We could have used 1, 2.3. You could have used 2, 2.4. We could have used 12, 2.1. It doesn't matter. Because this is a real world situation, even though this data follows this sinusoidal pattern, it may be imperfect. So if we choose a different month and plug it in, our phase shift may be slightly different depending on which data point we use. But because I'm forcing you to use, well, 6, 8.2, we're all going to have the same answer. So hopefully that's clear. All right. So everyone go ahead and solve for C. This is where your algebra skills come into play, and you want to, well, use those order of operations or whatever they're called, right? What's the first step? Minus 5.7 both sides, yes. So let me see what you guys said in pi divided by 6. Yeah. So remember, we never want to use rounded values. So if you did pi divided by 6 and you put a decimal value in your work, I'm going to mark the entire problem wrong. You never want to round your work until the final answer, ever. Keep it as pi over 6. Let's see what else we have. Pi minus 5.7. I don't know. I'm not really sure why someone wrote that. Pi minus 5.7.
I typoed. I accidentally hit the P.
Oh, okay. You meant minus 5.7 both sides. Okay. Okay, I got you. All right. Yep. Minus 5.7 both sides. And so we're now to here. So we get 2.5 equals 3.6 times sine of that stuff. We can reduce that pi over 6 times 6. We can reduce it down to pi. So maybe, Antonio, that's what you meant? You meant to simplify this to pi? Is that right? Okay. All right. Yeah, so, and this is still an exact answer right here. Pi is still exact. It's not rounded. All right, what's the next step? Not sure what you mean by expand.
You got to FOIL it out. You got to times this by that times that by that.
Definitely not. Definitely not. So I'm glad you brought that up. 3.6 times sine of the stuff. This is not 3.6 times this and then times this. Sine of this stuff is its own function, and you can't multiply in or divide out of a sine function. So that is an invalid operation. Sorry, but it's probably a common mistake. So I'm glad you brought it up.
Would you divide by 3.6?
We would divide by 3.6 both sides. Yes. So this is a product right here. This is 3.6 times the stuff. Something times something. To undo multiplication, you do division. So we divide both sides by 3.6. Okay. We're getting closer. All right. What's our next step? We have a fraction equals sine. What do we do? Arcsine. Yes. So addition and subtraction are opposites. Multiply, divide are opposites. Square roots and squaring are opposites. Well, signing and arc signing, those are opposites, and they undo each other. And we know that from geometry class from sophomore year. So we arc sign both sides. So arc signing the left side, arc signing the right side, and arc signing sine, they cancel out, they undo each other, and the stuff inside just carries down as pi minus c. We are getting closer.
Quick question. You did mean 2.5 here, right? Not 25 on both of these?
I do mean 2.5 and 3.6. Yeah, that is it's because I'm blind. It's a typo. It's a good thing it doesn't matter. But yeah, it is 2.5 and 3.6. My answer will be the same thing because it's just a multiple, right? I multiplied top and bottom by 10 by accident. But yeah, Antonio's right. It should be 2.5 and 3.6. So fix that on your paper. All right, what's the next step? Plus c to both sides. So I'm going to add c to both sides to make c positive. What else should I do? I'm going to do two things in one step, by the way. So adding c to both sides is one of the things. And what else?
Don't you want to simplify this?
Not yet.
You really can't.
It doesn't simplify. So do you mean type this in and give me a decimal? Is that what you're telling me? So again, you never want to have rounded work. So if you typed in inverse sine of 25 or 2.5 over 3.6 and you wrote me a decimal value and you put that in your work and you had more steps to do before your final answer, I'm marking the entire thing wrong. You can never round your work until the final answer. So you want to leave that as arc sine of that fraction until you do your final step to find c.
Okay, then I'm lost.
Remember, our goal is to get c by itself. So if I add c to both sides, I'm going to have c plus that arc sine equals pi.
Can you subtract?
There you go. Subtract it. Yep. We're going to add c to both sides and subtract arc sine both sides. Yep. So I did two things in one. Added c both sides and subtracted the arc sine both sides. All right. Now, for the final answer, we're going to type in pi minus arc sine of 2.5 over 3.6 in parentheses. It matters. And we're going to hit enter. And what do we get? And here, I do want you to round to 2 decimal places, because it says that. It says it right here. 2.37. Yes. So we're to the end of the problem. We know amplitude. Excuse me. We know amplitude. We know the K value. We know our C value, and we know the H value. So all we got to do now is just plug all those in for the final answer. And we're done. It's a lot of work. And yes, you do have one of these problems on your test. The quiz, I don't remember. For the test, 100% sure you have one. Like today's quiz or the unit test? Well, on your quiz, yeah, you're going to have word problems because that's what we're doing this section. It's only word problems for this section. So yeah, you're going to have word problems today. Yeah, you're going to have a problem like this. Or like one, you're going to have a word problem. I don't know if it's like this. Remember, every word problem is different. They're all different. You just have to approach them accordingly. All right, daylight. Let's see. This is, okay, we got 2 examples left. It's going to be a long lesson, guys. All right. That's a good picture. I found that on Google. All right, daylight. The table shows the number of hours of daylight on the 15th of each month in Queenstown, New Zealand.
I think it's Queenstown.
Okay. I meant to change that to like something else. I don't know why I put a picture of Arizona when it's not in Arizona. I should have found one for New Zealand. Whoops. Anyway, maybe they have cactus in New Zealand and they have sunsets like Arizona in New Zealand. I don't know. All right. So again, like last question, January is 1, February is 2, and so forth. All right. So we want to create a sine function with a positive when, I'm sorry, that should be alpha is positive, not just the regular letter A. I gotta change that in my presentation. When alpha is positive and whose X value represents the month. Okay. All right. So I'm going to quickly go through A, H, and P just because it's just the same thing from last question. So alpha is just going to be the max minus the min divided by 2. And that's how we get 3.4 for alpha. The height, so the vertical shift, which is what H is, we use that formula. I use the maximum minus alpha in this case. I thought it was easier, just like some of you have said last question. And that's how we get 12.18 for H. So we have alpha, we have H. To find period, well, we know period is 12 because there's 12 months and then it starts to repeat. So that's why P is 12. We plug that in and we solve for K, and that's how we get, just like last question, K is pi over 6. All right. Then we're going to plug in the stuff that we know. And this question does not say which month to use. So I chose the 9th month. So in your question on your test and your quiz, I'm pretty certain they're going to tell you which month to use to determine your phase shift. unless it follows a true sine wave, meaning the points are exact, which actually is not possible because everything is rounded to 2 decimal places. So I probably have to tell you which month to use. So I mean, in this problem, I'm telling you, use the 9th month. There you go. So we plug that stuff in. We subtract 12 points, whatever that number is, to both sides. We then divide both sides by 3.4. We then arc sine both sides. We are then going to do 2 things in one, just because I'm going to save room on my screen. We're going to add C both sides to make it positive, and we're going to subtract arc sine both sides. And then from this step, we are going to type it in. So everyone type that in. I want to make sure that all of you know how to round. And I want to make sure I know how to round too. So what's the answer, guys? $4.85. Maybe. So I only got 2 responses. Does that mean I only have 2 people still watching? Even though there's 11 people still in here? Oh, it's that Apple calculator. That makes sense. Yikes. Let's see if it's 4.85. It is 4.85. So now we have everything we need to construct our formula, our equation. And we get 3.4 times sine of pi x over 6 minus 4.85 plus 12.18. And we could type this into GeoGebra or Desmos and verify that we get these answers. Let me get my pointer out. We get these answers for the corresponding month. So when when x is 1, we should get this number. When x is 2, get this number, and so forth. That is an easy way to verify the final answer. Can we do one of the problems for Bellwork? No, we're actually out of lessons. The next lesson we have on Monday is going to be the review for the test. So I'll tell you what, I will, if you guys want, I will send you the review today that's blank through email. And that if you have the time and energy, which I hope you do, you can work out these questions. You won't have the answers until Monday, but you can work them out. And then Monday, I'll go through all the answers. Okay, so I will do that after class today. I will send all of you the review packet with all the answers and work removed. Right. On Monday, we're going to actually have the review session, and then I'm going to go through the answers to all those questions. All right. All right. All right. Same question. We still got another Arizona picture, even though this problem takes place in New Zealand. That's cool. Well, actually, no, this is a different question. Isn't it? Nope, same one. So again, this takes place. So when x is 1, when x is 2, when x is 3, it's giving you the time, the hours of daylight on the 15th of every month. So that's important. Now this question wants to know how much daylight will be on November 25th. Well, this value here, and when x is a whole number, it's for the 15th of every month. So that poses a problem when we want the 25th. So yeah, so November 15th is x equals 11. That should be clear. Oh yeah. I gotta. Oh man, see my mistakes. This is what happens when I spend hours on creating these lessons. I make like these little mistakes. Yeah. This is not sales. This is hours of daylight. Did I do that on the previous slide too? I sure did. I'm so good. I'm the best math teacher you've ever had. I can tell. Oh geez. All right. Anyway, November 15th. So x equals 11. November 25th. What about November 25th? What's some things we need to know about that day? Observations versus, so the 25th versus the 15th. Yep, 10 days. It's 10 days later. Yep. It is 10 days later. That is what I was looking for. It is 10 more days. So the 25th is 10 more days. So we have to do something to tack on a decimal value, right? A decimal or make it into a fraction. So how do I make 10 days into a decimal or a fraction? So Emily says it's a third. Yep. So for this problem, I forgot to state that we want to use, I do state it here. Yeah. So we're going to use 1 month is 30 days. So what Emily says is 10 days is 1/3 of the month. So we're going to take the 11 and then add a third to it. Exactly what we're doing. Mathematically, this is what we're actually doing. We're taking the 11 and we're going to add 10 times 1/30 because 1/30th is 1 day. So 10 times 1 day gives us that 1/3. And 1/3 plus 11 is 34/3. Decimal form is 11.3 repeating. All right. So from the previous page, we know the formula, right? So that's from the previous page. And it wants to know how much daylight is on the 25th of November. And we figured out X value is 11.333 forever, or 34/3. That represents the 25th of November. So what do we do? What do we do? Plug it in. Yeah, we plug it in. I don't know why I have this number here, or this little box. So what do I plug in right here? No. Why don't we plug in 11.3? It's rounded. Yes. You don't plug 11.3 because that's a rounded value. You cannot round your work. You round in your final answer. So you cannot put 11.3 because that's rounded. And if you plug in rounded values into your formula, your answer may be off. It may not be, but it may be. So you want to plug in the exact form, which is 34/3. The only reason why I put 11.3 here was, one, I wanted to confuse you to see if you'd actually pay attention and not use that value when you plug it in. And two, because I wanted to show you what the decimal equivalent was to the 25th of November in a form that's easier to understand. And 11.3 is definitely easier to understand than 34/3. That noise? You're hearing things. All right. Everyone type this in and then tell me what you get for your answer. What's the answer? Somebody. I know it's a lot to type in. Partly, I just want to see if I did it right when I worked this out. 15.19. Let's see if I got the same thing. Yep. So there's the wrote out quite a bit and then rounded 15.19. Did anybody type in 11.3 to see if you get the same answer? Can someone do that real quick? Emily's like, bye. Okay. Someone type in 11.3 and see if we get the same answer. It's off. So we don't get 15.19. Yeah. Yeah, and that's bad. So if you're working for NASA right now, you just crashed Perseverance into Mars, just so you know, and you just blew billions of dollars. So good job. You're now jobless. Never round your data. It could save a shuttle. I know, right? Every time you round your work in the middle, I flip a desk. That's what goes on in my head. I just want to just flip a desk over and yeah. Anyway, not really. I really don't. But don't round your work. You round your final answer. Now, sometimes you cannot avoid rounding work in certain situations, but those situations are probably very rare. All right, Ferris wheel. This is our last example. It is. Oh, we're almost done. So let's go through it really quickly. All right. So it says riders on a Ferris wheel get as high as 45 feet above the ground and as low as 5 feet above the ground. It takes 1 minute and 20 seconds for a rider to complete a full rotation. After the ride starts, it takes 16 seconds for Damien's car to reach the high points, which is Oops, I should have covered that up. Yeah, 16 comma. Oh, man, why did I? We're going to pretend that's not there. I did not mean to show that yet. All right. Says, graph the function that shows Damien's height above the ground X seconds after the ride starts. What cosine equation with a positive value of alpha and a phase shift to the right represent the graph? Okay. Well, amplitude, remember, we just used that formula. Max minus min divided by 2, so we get amplitude of 20. That's cool. To find the vertical shift, we use the formula max minus alpha, and that gives us 25. Okay. Pretty easy so far. Nothing new. This is like the last two problems. We're doing cosine. So again, 2 pi is the period. So we're doing p equals 2 pi. Oops. Let me back up real quick. So period. It tells us in this problem it takes 1 minute and 20 seconds to do a full rotation. What's the problem of me telling you it's 1 minute and 20 seconds? What's the problem of me saying 1 minute, 20 seconds? Wait, is it 1 minute, 20 seconds? At 1 minute, 20 seconds. Yeah, so Caitlin's right. We're using two measures of time. We're using minutes and seconds. We either have to convert it all to minutes or all to seconds. We can't have minutes and seconds. So let's convert it to seconds. So seconds, yep. Plus we can avoid decimals that way too. All right, so there's 60 seconds in a minute, so it's gonna be 60 plus 20 gives us 80 seconds. So in any problem where they give you two measures of, like in this case, time, you have to convert everything to be on the same unit. All seconds or all minutes or all hours, all years or whatever. All right, so now we can now figure out what the K value is. Period is 80. It takes 80 seconds to do a full rotation before it starts over. So P is 80. And we solve for K and we get pi over 40. All right, next, we plug in what we know. All right. So this is the parts right here. So I'm going to cover this now. So it says it takes 16 seconds for the cart to reach the high point. So that means when X is 16, the height is the max, which is 45. So when time is 16 seconds, we're at the high point 45. So we're going to use that as the coordinate to find the phase shift. So we plug in 16 for X, 45 for Y, and we just solve it like we did the last two problems. Subtract 25 both sides, divide by 20, arc cosine both sides, add C to both sides, subtract arc cosine. Oh, I just copied it over there. I didn't actually do anything, did I? Okay, I just copied it over there. Okay, now we do what I just said. And then we type it in. So everyone type it in for me. But remember, we want, I want you to round it because it does say, what does it say? Yeah, so I want C to be rounded to, I don't actually state it here, do I? Yeah, leave it in exact form, sorry. You're right. Yeah, I do want to, if you can give me exact form, give me exact form. Sorry. So now we have all that stuff and we just plug it in. And then there is the formula for the equation. Oh boy, this is a lot, huh? It's a lot of work. The one more is more of like an explanation. It's not actually doing the problem. So yeah, unit 4 is worse. All right, so I feel like I took this problem from your practice module. I don't know if I did or not. I can't remember. All right, so in your module, it's gonna, like, we have the equation here and it wants us to graph it. Well, it's gonna give you directions like, you know, first plot the midpoint, then plot the point closest, or like a min or a max, right? So you want to click, well, the midline, well, you have to know what the midline is, which we found on the previous page is 25. So you want to click here. So you click that point first, and then we plot the max or the min. Well, I know on your quiz yesterday, if you plotted the min, which is like over to the right more, it marked it wrong. So I guess it wants you to go to the left of your midline and plot the min or the max of whatever it is. In this case, it's a max. And the max is 45. So we plot that point next. So yeah. And that's, you know, you find these values. You can either plot it in Desmos or just use the shifting from the previous page. Actually, even from this page too. Like we know what the amplitude is. We know what the vertical shift is. We know what the phase shift is. Phase shift is 2 pi over 5. But then you have to actually divide this by k. And k is, where was k? K is pi over 40. Yep, pi over 40. So the actual phase shift is c divided by k to find this actual point out, just so you know. But anyway, yeah, so that's how you plot them, guys. Midline and then the max value, and then it'll plot the graph for you. This page?
Yes. Yes, thank you.
Yep. All right, you good? And I did, I'll post it again. There's the link to the actual lesson. You can actually view it that way too. But yeah, there's the formulas that were earlier on in this lesson. And well, guys, thanks for sticking around to the end. I know it was pretty long and a lot to take in, but yeah, I hope you learned something.